I'm going to work through some of these problems from the Math 2 Honors Solving Trigonometric Equations. And the first part, numbers 1 through 10, ask us to identify the possible quadrants in which the terminating ray for theta could lie. And to do this, I'm going to use a couple ideas. So first of all, in a unit circle, pick any point on that circle and say that coordinate xy, we know the x coordinate represents the cosine of theta, and the y value represents the sine of theta, and the tangent is the sine divided by cosine, so in this case it would be the y value over the x value. So in number 1, our cosine is positive. It's greater than 0. And this is really saying for what quadrants is x greater than 0? And that's true on the right side of the graph, so that's in quadrant 1 and quadrant 4. Number 2 is asking where's sine greater than 0, or where's the y value greater than 0? And that's the top half of the circle, so that'd be in quadrants 1 and 2. Number 3 is asking when is the tangent equal to 0? Well, that's asking when's the ratio of x and y positive? Well, that's when x and y are both positive, so that would be in quadrant 1, or it's when they're both negative, which would be in quadrant 3. Number 4 is asking where cosine's negative, or where the x value is less than 0, and that's on the left side of the graph in quadrants 2 and 3. Number 5 is asking when the y value, or sine, is negative. That's the bottom half of the circle in quadrants 3 and 4. 6 is asking when tangent is negative, or when y over x is negative. And so that's when either y is negative and x is not. So that would be in quadrant 4. Or when x is negative and y is not. And that would be in quadrant 2. So 2 or 4. Number 7 is saying that the cosine squared theta is greater than 0. Or in other words, x squared is positive. Well, that means x could be positive or negative, which happens in all the quadrants. So 1, 2, 3, and 4 is our answer. Same idea with the sine. This is saying, hey, y squared is positive. That can happen in any quadrant. So 1, 2, 3, and 4. Tangent squared is negative. So you square the tangent, or you square some number, and you get a negative value. That's not going to happen with real numbers, and so that does not happen anywhere. So we'll just say not possible. And lastly, number 10, the tangent squared is positive. And so you're taking your y over x, you're squaring that, and getting something positive. So it could have been positive or negative. That happens in any quadrant as well. Whenever you square a number, you get a positive answer, as long as that number is real. Alright, so now for number 11 through 14, we're asked to solve for all values of theta, such that theta is between 0 to 360 degrees. And then we're to give all answers in degrees. Okay. So on number 11, we first get sine by itself by adding 1. So 2 times the sine of theta is equal to 1. And then the sine of theta is 1/2. Then we ask ourselves two questions. In what quadrants is the sign positive, just like we were asking ourselves in 1 through 10. Well, if the sign's positive, that means the y value is positive. And that happens in the top half of the circle in quadrants 1 and 2. So each quadrant gives you an answer. We have 2 quadrants here. We're going to get 2 answers. The second thing we want to know is, what is our reference angle? And we have 3 choices, 30, 45, or 60. And the sine of which angle is 1/2. And you try them out, however you want to come up with it. We end up with 30 degrees. The sine of 30 degrees is going to give us 1/2. So 30 degrees is our reference angle. I'll put theta prime is 30 degrees. And so then lastly, to get our answer, we're going to put our reference angle 30 degrees in those 2 quadrants. So one in quadrant 1, another in quadrant 2. And so in quadrant 1, we're pointed at 30 degrees. In quadrant 2, we're pointed at 150 degrees because it's 30 less than 180. So those are our answers. Theta is 30 degrees and 150 degrees. For number 12, we solve for cosine. By subtracting 1, you get 2 cosine theta is -1. And then divide by 2 and you get the cosine of theta is -1/2. And we ask ourselves those 2 questions again. In which quadrant is cosine negative? Well, that's your x value, and you want x to be less than 0, negative. That happens on the left side of the graph. That's in quadrants 2 and in quadrant 3. So again, 2 answers that we're looking for. And then next, for our reference angle, the cosine of what angle is 1/2? And you can ignore the negative part in this question. We just need to know what our reference angle is, theta prime. And you try things out, and you end up with 60 degrees, because in a triangle with hypotenuse 1, across from 60 is going to be a length of √3/2, and the side adjacent would be 1/2, and that which represents the cosine of 60. So we're looking at 60 degrees. So for our answer, in quadrant 2, I'm going to put a reference angle of 60 degrees, and in quadrant 3, a reference angle of 60 degrees. And this is 180 degrees, and if we go 60 back from 180, we're at 120. If we go 60 after 180, we're at 240, and those are our 2 answers. Theta is 120 degrees and 240 degrees. Number 13, solve for tangent by subtracting 5, and you get 5 times the tangent of theta is -5. Divide by 5, you get tangent of theta is -1. And so then you're asking, well, when is tangent negative? And we even we asked ourselves that back in number 6. And we answered, and we got quadrants 2 and 4. So we know we're going to have an answer in quadrant 2 and 1 in quadrant 4. Secondly, what angle, or the tangent of what angle, gives us 1? And you try your 30, your 45, and your 60, and the 45 is what's going to work out, because if you have a 45, 45, 90, the sine of 45 is √2/2, the cosine is √2/2, and when you do a sine over cosine, you have the same quantity, and you're going to end up with 1 for the tangent. So 45-degree angle is our reference angle, and that's what we're going to put in quadrants 2 and 4. Something like that. And so 45 back from 180 degrees is going to be 135 degrees. And 45 back from 360 degrees is going to be 315 degrees. Those are our two answers. Theta is 135 degrees and 315 degrees. Number 14, we're solving for tangent again. We get root 3. Tangent theta is equal to 1. Divide by root 3. Tangent theta is 1 over root 3. We can leave it in that form. It's not the form we would prefer. You know, we like root 3 over 3. But we're not solving for tangent. We're trying to find theta in this case. So tangent is positive in which quadrants? Well, if we look back at number 3, we found it's positive in quadrants 1 and 3. And so that's where our answers lie. And so we get two answers. And then we want to know what angle gives us the tangent of theta is root 3 over 3. And it may have to do you have to do a little trial and error, but if you try 30 degrees, the sine of 30 is 1/2. The cosine is root 3 over 2. And when you go sine over cosine, you get 1/2 divided by root 3 over 2, which is 1/2 times 2 over root 3. 2's cancel out or divide out, and you end up with 1 over root 3, which is what we have. And so we find that our reference angle is 30 degrees. So put 30 degrees in quadrant 1 and in quadrant 3. And if you go 30 past 0, you're at 30 degrees. That's one answer. If you go 30 past 180, you're at 210. That's the other answer. So theta is 30 degrees and 210 degrees. For 15 to 21, we're asked to solve for all the values of theta such that theta lies between 0 and 2 pi, and we're working in radians this time. So same thing as before, but now working with radians. Solve for cosine. Add 1, you get 2 cosine squared theta is 1. Divide by 2, cosine squared theta is 1/2. And we got to get rid of that squared, so you take the square root of both sides, and you get cosine theta is the square root of 1, which is 1, over the square root of 2. If you multiply top and bottom by root 2, you get root 2 over 2. So cosine is positive. And if we look back, we found that cosine is positive in number 1 in quadrant 1 and 4. So two answers. And the cosine of what is root 2 over 2? You try 30, you try 60, and you find out it's actually at 45 degrees. But we're working in radians here, and pi is 180, and 180 divided by 4 is 45 degrees. So 45 is pi over 4. So, to get our answer now, put 45 degrees in quadrants 1 and in quadrants 4. But we're working in radians this time. So at 0 radians, we're going to go forwards pi over 4, and we get pi over 4. And if you keep going around, you're at 4 pi over 4. And keep going around, you're at 8 pi over 4. But we need to go back pi over 4, and we end up at 7 pi over 4 in quadrant 3. And those are our two answers. Theta is pi over 4 and 7 pi over 4. Number 16. 16, we add 3 to both sides and get tangent squared theta is 3. Take the square root of both sides, get tangent theta is the square root of 3. Now, careful here, because we got tangent squared is positive 3. And when you square anything, it's positive. So the tangent itself could have been positive or negative. Well, looking back, if tangent is positive or negative, or you could see number 10, if tangent squared is positive, this could happen in all 4 quadrants, and that's what we're working with here. We're going to have 4 answers, one from each quadrant. All right, now we're after, well, what angle is going to give us root 3? And if we try 60 degrees, we know the sine is root 3 over 2, the cosine is 1/2, and if you try the sine over cosine, you get root 3 over 2 divided by 1/2, or root 3 over 2 times 2 over 1, which reduces to root 3, and so 60 degrees is our reference angle. So you put 60 degrees in all 4 quadrants. But we're not working with degrees, we're working with radians. So 60 degrees is the same as pi over 3 radians, because pi is 180, and 180 divided by 3 is 60. So we got 0, we're going this way, pi over 3. That's our first location. We go half circle at 3 pi over 3, and we go back pi over 3, and we get 2 pi over 3. And we go forward pi over 3 and get 4 pi over 3 from 3 pi over 3. And then if you go another full half circle, we're at 6 pi over 3, and go back pi over 3, and we're at 5 pi over 3. So theta is pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Number 17. 4 times sine squared theta minus 1 is 0. Add 1. Divide by 4. Take the square root, and you end up with sine of theta is positive or negative 1/2. And if we look back at number 8, sine squared theta was positive. That happens in all 4 quadrants. That's what we have here. We have sine squared theta is positive. Going to happen in all 4 quadrants. Got 4 answers. We said already back at number 11 that sine of 30 degrees is 1/2. So that's our reference angle, 30 degrees. And we said a couple back that 30 is pi over 6. And so now put 30 degrees in each quadrant. And count by pi over 6. So 0 radians, so first place is pi over 6. Go halfway through, and that's 6 pi over 6, which is pi radians. And then go back pi over 6, and you're at 5 pi over 6. Go forward from 6 pi over 6, and you're at 7 pi over 6. Go a full half, and you're from 6 pi over 6, you're at 12 pi over 6. And go back 1, and you're at 11 pi over 6. So those are our 4 locations. Answer is theta is pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Number 18. Solve for cosine squared first. So you got 4 cosine squared theta equals 3. Cosine squared theta is positive 3 over 4. And we found in the first part of our homework that if we have cosine squared is a positive, then that's going to give us an answer in each quadrant. So we have 4 answers. Take the square root and you get cosine theta is the square root of 3 over the square root of 4, but we know the square root of 4 is 2. And the cosine of what angle is root 3 over 2? Well, that's going to happen with 30 degrees. So theta prime, or reference angle, is 30 degrees, which is pi over 6. So we're going to put 30 degrees in all 4 quadrants, which is exactly what we did in the previous problem. We're going to get the exact same answer now. So theta, I'm just going to copy the answers: pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, moving on to number 19. Let's solve for tangent. We get 3 tangent squared theta is negative 1. Tangent squared theta is negative 1/3. And so we have the tangent squared is a negative. Well, if you square any number, you should be getting a positive answer. And so there is no solution to number 19. And then our last two, number 20 and 21, they are factored for us. And so we actually need to split them into 2 cases. So our first case, 2 sine theta plus root 3 is 0. Our second case is that sine squared theta minus 1 is 0. So in each case will give us 2 answers, or maybe more. And so then we'll combine all those answers at the end. So in the first case, we end up with 2 sine theta is negative root 3. So sine theta is negative root 3 over 2. So that sign is negative in quadrants 1 and 2. And the sine of 60 degrees is root 3 over 2. So that's our reference angle. We ignore the negative in this case. And so we're going to work with pi over 3 in those 2 quadrants. So in quadrant 1, put 60 degrees. In quadrant 2, put 60 degrees. And we're going by pi over 3, so 0, this is pi over 3. Go full half circle, which is 3 pi over 3. Go back pi over 3 and get 2 pi over 3. And so those are 2 answers. But we still need to do the right half. So in the right half, we get sine squared theta is 1. So this is going to be true, positive in all quadrants. But careful here. Sine is 1. That's a kind of a rare case, because when you take the square root, we end up with sine theta is positive or negative 1. Think about the unit circle. Has a radius of 1. Sine is the y value. So that's going to only happen at 2 spots. These 2 locations, we know the points. 0 positive 1 and 0 negative 1. And so what are those in radians? Well, we know 90 degrees is pi over 2. Count by pi over 2 again, you get 180 is 2 pi over 2. And so then we're going to get 3 pi over 2 at the 270 degree mark. And so those are two answers. So put all four together, and we end up with theta is pi over 3, pi over 2, 2 pi over 3, and 3 pi over 2. And that's the answer to 20. All right, last problem, 21. Split this up again. Tangent theta plus root 3 is 0, so tangent theta is negative root 3. If tangent's negative, that happens in quadrants 2 and 4. And tangent of what angle is root 3? That is tangent of, well, that's going to happen when you get root 3 over 2 over here, 1/2 here, 1 here, and so that's 60 degrees, which is pi over 3. And so put 60 degrees in both quadrants, 2 and 4. Count by pi over 3, so here's 0, go half circle, 3 pi over 3, go back, 2 pi over 3 is one of the answers. Go full circle, 6 pi over 3, go back, 1 pi over 3, and get 5 pi over 3 is another answer. So that's the left half. Now for the right half, tangent theta is 1, because tangent theta minus 1 is 0. And that's happening, well, tangent is positive in quadrants 1 and 3. And the tangent of 45 degrees is 1. And 45 degrees is pi over 4. So put 45 degrees in quadrants 1 and 3. So we're going to count by pi over 4. So the first location is pi over 4. Keep going, half circle, 4 pi over 4. Go another pi over 4 to 5 pi over 4. And those are our two answers there. So put those together. So in quadrant 1 we have pi over 4. In quadrant 2 we have 2 pi over 3. In quadrant 3 we have 5 pi over 4. And in quadrant 4 we have 5 pi over 3 as our four answers.